Hello there. Welcome to our quantities in chemistry unit. Up to this point, we've been looking at reactants and products and identifying them and putting them in little categories, single displacement, double displacement, that sort of stuff, and looking at matter as it is and comparing this type of crystal with that type of crystal and polar and non-polar and all that jazz. That stuff's all qualitative. From here on, we're going to be looking at a lot of quantitative chemistry, which is making measurements and making predictions based on those measurements. And so this first lesson is going to be all about measuring things and deciding what parts of those measurements are significant. So whether it's a volume, like the volume of this liquid in this graduated cylinder, or a mass, like this weigh scale here, which has pounds and kilograms on it, or temperature, like this thermometer here, which has Fahrenheit and Celsius on it. That's what we're going to be using throughout this unit. And so all those measurements are going to have limits that we call significant digits. Okay, all measuring devices have a limit of accuracy that we use when we are going to make measurements related to chemistry. So it might be gas chemistry, we might be measuring pressures, so you could have pressures like kilopascals and pounds per square inch like on this pressure gauge. Or it might be volume, where you're measuring volumes based on how much of a liquid goes into a container. And so there's limits to how accurate each of these devices is. You can see there's numbers on here, and then there's lines between the numbers. And so you can really only be as accurate as what those gradations can tell you, and you can estimate a little bit in between them. So that's what we're going to start with, is how to make measurements and what limit of accuracy we can have. So significant digits is how we communicate which of our measured values are meaningful, which of the ones came from an actual device with its degree of accuracy that it might have. First of all, if it's counted, if you counted the number of a thing, then that's infinitely accurate. But whenever you're using a scale or a measuring device, there's going to be some place on some limit to the accuracy of the scale. I think this little ruler activity here or illustration will show what I mean. So whenever you are using a measuring device, what you do is you read all of the digits that you can from the device, and then you add one more that's an estimate. So with ruler A here, we can read 1, 2, 3, 4, and it's not quite 5, but we can estimate it's somewhere between 4 and 5. We might estimate this as 4.8. So we might say 4.8. So the 4 we read right off the device, and the 0.8 is the estimated one. So there's always going to be one estimated value, regardless of what type of measuring device you use. The last number, even the number on an electronic scale, that last one is an estimate. It's not infinitely accurate. So if we look at this second ruler here, we see that it has more gradations, and we can see that we can measure the 4, but we can also, there's 5, 6, 7, 8, and then we can estimate that last bit there. So we can say 8.5, so it'll be 4.85. So this one is a lot more accurate. We read those values, and then we again estimated the last one. So all of your significant digits will include one estimated value on the end. Now there are guidelines to follow when you're reading someone else's measurements to decide which of the digits are significant. So we'll go through them now. First of all, anything that's not a 0 is significant. So if you have the number 345, whatever the unit is, all 3 of those numbers are significant. Zeros that are in between non-zero digits are also significant. So if it's 305, since that 0 is in between, significant. Zeros that are leading are not significant. We call these placeholders. So they make sure that the 3 and the 4 and the 5 are in the right place, but they themselves are not measured. So only 3 significant digits there. Now, the only time when you have a 0 that is significant is when there's a decimal. When there's no decimal there, then it's not significant. So again, this is 3, 4, 5, and that 0 again is a placeholder, just like this placeholder here. It's a placeholder. Just make sure the 3 and the 4 and the 5 are in the right column. And so that's 3 significant digits. However, as soon as you put a dot in there, that means that this was our estimated value, estimated to be bang on the 5, right? So then you have to include it. So you only include it if you see a decimal. Sig figs and sig digs. A memory aid to help you decide whether digits are significant or not. It's called the A&P method. So the way it works is if a decimal is absent, you start from the Atlantic side and you will go to the left, starting to count from the first non-zero digit. So we'll start from the Atlantic side and go that way. That's a 0, that's a 0. 1, 2, 3. 3 significant figures or digits. If the decimal is present, you're going to start from the Pacific side and go to the right. And you do the same thing. So you start over here. That's a 0, that's a 0. Not a 0, yay. 1, 2, 3. You just go until you run out of digits. Also 3 significant digits or 3 significant figures. Figs or digs, your choice. Alrighty, let's give this a try. For this first one, I don't see any decimals, so it's absent. We'll start on the right. That's a 0 though, so 1, 2. 2 significant digits. Second one has a decimal, so we'll start on the left. So not a number 0, 0, 0. Oh, 1, 2. 2 significant digits. Next one, decimal is absent. 1, 2, 3 significant digits. Next one, decimal's present. 1, 2, 3, 4 significant digits. Oh my goodness, it's going up. Decimal's absent. Start from over here. 1, 2, 3, 4, 5 significant digits. And the last one goes with the hint at the bottom. Anything written in scientific notation, all the digits are significant. But not these ones. That's the power thing. All the values, 1, 2, 3 there. Those are the significant values. Now, oftentimes when we make measurements, we're going to use them to do calculations with. And so once you do that, the number of digits you might get at the end of the calculation might be more than what we should have for our significant digits. So we have to have a few guidelines to follow when we're doing calculations with significant digits. So we're going to start with adding and subtracting, right? And what you do is you look at the number of digits after the decimal, and you got to go with the least accurate one here if you're adding and subtracting. So that is 1 after the decimal. This one has 2 after the decimal. So in our final, we can only keep 1. I'm going to keep the least number here. So let's see what it comes out to on my calculator. 123.6 plus 16.23 equals, I got 139.83. And so what I'd have to do is round this back, get rid of that guy. And so the answer would have to be 139.8 to stick with the least accurate value. You can't be more accurate than your least accurate measurement. Okay, same thing with subtracting. 123.6 minus 16.23 equals, and this time it's 107.37. We can only keep 1 after the decimal, so we're going to get rid of this guy, and we could round that then to 107.4. There you go. Only as accurate as your least accurate measurement. Now for multiplying and dividing, it's similar, only instead of looking at the digits after the decimal, you're looking at total number of significant digits. And so when you have a quantity like this, where you're, say, multiplying for an area, you can see that that is 3 significant digits, and this is 2 significant digits. And so when I do my multiplication, I get 4.56 times 1.4 equals, so it comes out to 6.384. So I can only keep 2 of those digits. So we go with 6.4. Okay, and we'll look at this other one here. It has 3 significant digits. That has 2 significant digits. So 41.1 divided by 5.2 equals, and it comes out to 7.90384, right? But I can only keep 2 since that's the least number of significant digits from the problem, from the measurements. So got to chop up all these, just go with 7.9. Hope that makes sense. Okay, so you saw in several of those functions we had to round off to get the right number of significant digits. Rounding follows some pretty simple rules, but there is one that's a little weird. So if it's between 1 and 4, most people know this. If you're rounding, you have something between 1 and 4, you're going to round down, so this would just be 52. If it's between 6 and 9, the number that you're rounding off, this guy, then it's going to round up, so 53. If it's a 5 and it's on the very end, then you're going to do what's called rounding to even, right? So 1 to 4 we go down, and 6 to 9 we go up. But if it's a 5, you're going to round to the nearest even value, which means some of the time you're rounding up and some of the time you're rounding down, and it's sort of a statistical thing. So hopefully, overall, it'll balance out and you won't have skewed data. But it doesn't really happen that often. So when you have a 5 on the end, just round to the nearest even value. So if it was 52.5, the 2 is even, so you just leave it as 52. If it's 53.5, the nearest even value is 54, and so you round up for that one. So there you go. So half the time you'd be rounding up, half the time you round down. Overall, it balances out. And that means that when you're rounding, you should not have any bias. All right, so let's try a few here before we finish up. Let's do this on the calculator. I got 72.45 plus 41.456. And that equals 113.906. But I got 3 digits here and I only got 2 there. That means I have to round that off, and that will round up, so 113.91 centimeters. Great. Next one, 821.24 minus 799.6 equals 21.64. That has 1 after the decimal. This has 2 after the decimal. I have to go with 1, so we're going to get rid of that guy, which means just 21.6 milliliters. We got a multiplication one here. 17.5 times 55 equals, I got 962.5. And so that's 3 significant digits, and that's 2, so I can only keep 2. So that would mean chopping off here. We can use placeholders, so it's 960, and that would be meters. Okay, this last one, it's a division, so 946.5 divided by 122. 946.5 divided by 122 equals, and I get, what is that? 7.758. 7.758. 19, blah, blah, blah. Okay, so we're going to keep, we have 3 here, we have 4 here, so we've got to keep 3 in our answer. So we're going to chop it off there. So that comes out to 7.76. And the unit would be grams per milliliter. All right, hope that helps and you understand your sig figs and rounding. See you soon.